Okay, so now we're looking at question 2 of the September mock. So it launches straight into, there's no sort of preamble here. Okay, so consider the following pair of isomers. So I think it's going to be helpful for us to think about what functional group they have, what type of compound they are before we begin to name them, or name the one that we have to do. So we consider the following pairs of isomers. If we look at C, it's got a carbonyl bond and the same carbon also attached to an oxygen. So that is an ester. Okay, that's important. Helps us sort of then think about when we're doing something in a second. And then if we look at the other molecule, it's also got a carbonyl bond, but instead of being bonded to an oxygen, which has then got an alkyl group, which is what the ester has, it's bonded to an OH, so that makes it a carboxylic acid. Okay, so it says name compound C. So the names of esters come like in two parts. So the first part of the name is the alkyl group that's attached to the oxygen. All right, so that's the first part of the ester name. And we've got 3 carbons, and it's going to be propyl. And then the second part of the ester name, the part that goes anoate, you have to make sure that you're looking at the carbon that is part of the carbonyl and what else is attached to it. So there is actually only the carbon in the carbonyl and no other carbons attached to it. So that makes that methanoate. And so our overall name then is propyl methanoate. So in esters you do have a space between the words. Okay. I mean, if that's something that you're not sure about, then naming esters is a straightforward thing to go back and look at the video about esters that I did, or about carboxylic acids and derivatives. Find the one on esters, and then, or you can get in touch with me and say you want to do further practice on naming esters or something. All right, so identifying a reagent which could be used in a test tube reaction to distinguish between C and D. In each case, state what you would observe. So there will be choices for something like this. But I'm going to go for the standard. All right, it's the most common examples. There's no point me listing all of them to you because that will just potentially be confusing. If we think about, what is the significant difference between these two compounds is that one's an acid and one isn't. Okay. One is a weak acid, one is not. So we should use a reagent that is going to show us that something is an acid and then something that isn't. And so probably the best thing to go for is a substance like sodium carbonate or sodium hydrogen carbonate. The reason to go for sodium is that any all group 1 compounds, ionic compounds, are soluble, so you'll know it'll be a solution. So I'm going to put sodium hydrogen carbonate. All right. Now, but it could be sodium carbonate, and it could be any other carbonate. To be honest, they would allow that. Now, if you write a formula, so if instead of writing the words sodium hydrogen carbonate, if you did that and you got the formula wrong, you wouldn't get the mark. So please, if you're at all not confident when you're writing an answer of remembering the formula, then write it as a name instead, and you will definitely get the mark if you write the name correctly. If you If you write the formula incorrectly, you'll, I'm afraid, not get that mark. So observation with C. So if I add my sodium hydrogen carbonate, which is a base, to my ester, there will be no reaction. And I think when it says observation, if there's no observation, just put no reaction. They're absolutely fine with that. Okay, that's you saying there is nothing observed to suggest that a reaction has taken place. And then the observation with D is, well, you've got a sodium hydrogen carbonate with a weak acid or with an acid. So one of the products that you get when you do a carbonate or hydrogen carbonate with an acid is carbon dioxide. So you'll see fizzing, bubbles. You do not have to run it through lime water to show it's carbon dioxide. It's useful to know that as a technique, but when it's about identifying a reagent that is a weak acid or an acid and something else that isn't, you don't have to do the lime water part of it. You just need to recognize that there's fizzing or bubbles. Okay. So consider the following pairs of isomers. So let's do exactly what we did on the previous one. Let's look for functional groups. So we've got a carbonyl. It's bonded to a C on one side and it's bonded to another C on the other side. So that makes it a ketone. And then if we look at the other one, we've got a carbonyl again. One side is bonded to a carbon, but the other side is bonded to a hydrogen. So that makes it an aldehyde. So name compound E. So if you remember on the first video, the one where I went through question 1, the very first question was naming a compound, and we talked about strategies, or I talked about strategies. And so the first thing to do is to find the longest sequence of carbons, the longest chain, and that's the longest chain, right? And there are 5 carbons there, so it's pent. We can see that it has a carbonyl group, and that was next to, well, basically what I've highlighted in yellow, right? What I've highlighted in yellow, we've got a carbonyl group, and we've got a carbon on that carbon in the carbonyl is bonded to 2 other carbons. So that makes it and we've said already it's a ketone, so that's going to be one. Okay. But we also should do that whole counting thing, because if you get into the habit of doing this, you're less likely, well, you're less likely to make a mistake on the number, but secondly, you're less likely to forget to put a number in. So that carbonyl could have been on a different carbon. It could have been on the 3rd carbon. We start at the end that the carbonyl is closest to, so that's why I started on the left. It's not automatic that you start on the left, but you might sometimes have to count from the right. You're having to make a decision about that. If you want to appreciate how to make that decision a little bit better, then I suggest you watch the videos on the Introduction to Organic Chemistry that I've got up there. So we have got, what we've got here is a 2-one. Okay. And then finally, the rest of the compound is fully saturated. So that means it's actually pentan. So the name of the compound is pentan 2-one. So pent because there's 5 carbons, pentan because it's fully saturated. Then we're looking at the functional group, which is it's a carbonyl, but it's a ketone, sorry, so it's part of the ketone family, so it's one, but that carbonyl, it could have been on a different carbon and still been a ketone, so we have to make it clear it's the 2nd carbon, so it's pentan 2-one. Okay, so now it's another testing, it's another, and there is no real strategy to this other than you learn your chemical tests for the different families, the different homologous series. Ketone aldehyde is such a standard it's such a standard question to have an aldehyde and ketone and how to distinguish between them. It's so standard. This is a gift of a question. This is really truly easy marks, providing you've spotted and recognized it's a ketone and one's an aldehyde. And again, strategies, write the homologous series underneath the structure. Know straight away that it's a ketone. Know straight away that it's an aldehyde. Don't wait till the question, don't wait till it becomes relevant, because it will become relevant. Okay. So identify the reagent. So I'm going to go with Tollens. Okay, reagent. And with a ketone we get no reaction. We're not having to explain what's happening here, all right? We're not having to explain why one does something and one does the other. I'm going to do it in a second for you, but we don't have to do it for the actual to get the marks. And then here we get a silver mirror. The other common test, so I am going to write the other test, that one that's common. So let's do it in that blue. The other common one that you could do is failings solution. And again, we would write no reaction. And for this one, we would say a red precipitate. You must say precipitate or red solid. You can't just say goes red, I'm afraid. So essentially the reason why we're getting a positive test with an aldehyde and a negative test with ketones for both of these, for both Tollens and failings, is that a ketone can't be oxidized any further. So it can't be oxidized to a carboxylic acid, and therefore a redox reaction can't take place, which means we can't reduce whatever the other species is. Whereas with the aldehyde, it can be oxidized to a carboxylic acid, which means in the case of Tollens reagent, the silver ions in the solution can be reduced to silver metal. So that's why we get the coating, that's why we get the silver mirror. Or in failings, the copper is reduced to copper 1+. So it goes from copper 2+, that's why it's blue to begin with, to copper 1+, so it forms a red precipitate. So there is a redox reaction going on in the case of the aldehyde, and no reaction whatsoever in the case of the ketone. And then finally, draw the structure of the chain isomer of F, which shows optical isomerism. So it says it's a chain isomer of F. So what that means is we have an aldehyde group still. It's still an aldehyde. Okay, so that's very important. So we are drawing F, but we are having a chain part of it as opposed to the completely sort of linear molecule, or linear, but sort of straight chain molecule that it is. Now, the way to approach drawing optical isomers, or not even drawing them, sorry, to determining them, because we only have to draw the structure, we don't have to draw it in its three-dimensional shape, is for something to be how it show optical isomerism. It's the carbon we're focusing on. It's focusing on a carbon, which has 4 different groups. And we've now got to, from our molecule, we've got to decide on we've got to decide on which what's joined to it. So always one of them is an H. I mean, just draw the H. And quite typically, think if the functional group, or the thing that makes it a particular part of the homologous series, that's typically something that's hanging off the chiral carbon. So let's draw our aldehyde. And as you're doing this, you're using up part of the molecule. So if I go back to the aldehyde, let's actually just work out its molecular formula. So I've got 5 carbons, and I've got 1, 3, 5, I've got 10 hydrogens and 1 oxygen. Okay, 10 hydrogens and 1 oxygen. So if I can do it like a running tally. So I had 5 carbons, 10 hydrogens, 1 oxygen. So far I have used 2 carbons, so I've got 3 left, and I've used 2 hydrogens, so I've got 8 left, and I've used my oxygen, so I've got 0 of those left. Then another typical thing, and sometimes you've just got to have a go and then work out whether it, at the end whether it's worked or not, right? But a hydrogen is always going to be off a chiral carbon, and given how many carbons you're ever going to have in a A-level question, I think the maximum is 6 or 7, and I think it's probably 6. It's a methyl group is typically 1 as well. So that means we have used another carbon, got 2 of those left, used 3 of those, so got 5 of those left. And so really all we can do that's different from anything that we already have is to do an ethyl group. So that's now 0 and that's now 0. So we've used everything. So let's now look at our carbon in the middle. So we're looking for essentially four different groups, four different parts attached to it. So there's one part, there's another part, there's another part, a different colour, and there's another part. And so we have our 4 different things. And is it a chain? Yes, it is, because if I do the longest chain, so obviously the carbonyl is going to be part of that longest chain. The longest chain is there, and we do have a branch. So we have satisfied the fact that it is a chain isomer of F. Right, that's what we've done. And that is the end of that question. So if you have any queries, let me know, and I'll do my best to help.